All right, let's talk turning points, degrees, and multiplicities. We've already talked about some multiplicities, but how does this relate to turning points and what are turning points? So, first off, turning points are where the graph turns and changes direction. So let me give you a quick example on this first graph. If you're following along and you start on the left side of this graph, that'd be down here. I want to think about this as a road and you're a car driving on this road, okay? And so you're like, dee-dee-dee, dee-dee-dee, dee-dee-dee. Well, a turning point is where you are going around a curve and you have to turn your steering wheel. So, da-da-da-da-da. Oh, right here, I got to turn. I got to turn. So this very maximum point in that area is going to be a turning point, okay? Are there any others? Let's see. I'm driving some more, I'm driving some more, I'm driving some more. Oh, wait, I got to turn right here. That right there is a turning point also. So a couple things to note, or at least one thing to note about a turning point, is that it does not always land on the x-axis, okay? Sometimes it does, and sometimes it doesn't. And when it does and doesn't means something, okay? And we're going to talk about that real quick right now. So let's first do this. The first question on this problem that in this graph that we've been given is what are the x-intercepts? So we want to go along here. Here's our y-axis, there's our x-axis, and let's find our x-intercept. So we know that we have an x-intercept right here and one right here. I'm going to actually take this green off for a moment. Okay. All right, so what are those numbers? So let's look at this one. This one would be what? -2, 0, and the other one would be 1, 0. Okay, number of turning points. So we want to count our turning points. I just talked about turning points, so we have 2 of those. Now, how does this relate to the degree of the function? So we have up here, if a graph has t turning points, then this is the, sorry, I think there's a word missing there or something duplicated, but the least possible degree of the function is t plus 1. So that t plus 1 is what we are concerned about. So this is t. So the number of turning points would be t, in this case 2. Then the least possible degree is t plus 1. So this would be 2 plus 1, which would be 3. So long story short, the least degree that can possibly be had on this graph is 3. And we always say the least possible because technically you could actually have a higher degree. And the reason is because of the multiplicities. We cannot clearly see multiplicities here. What we can see is a couple different things. We see that at this turning point, that is also an x-intercept. Okay, and because those two things are the same thing, a turning point and an x-intercept, that means that it bounces. That means it bounces right here. That means also that that multiplicity is even. And if we think about even multiplicities, the smallest even number is 2. It could also be 4. We're not sure. That's part of why we say least. Okay, but we know that it's at least 2. And then if we look at this one, what do we know about the graph there? That's an x-intercept, but it is passing through. This is a pass-through. Okay? And if it's passing through, that means it's an odd multiplicity, and the smallest odd number is 1. Now, it doesn't have to be 1. It could be 3. It could be 5. We don't know, but we know that the least there is 1. And so if this is 2 and this is 1 and those are multiplicities and I add those together, that gives us our least possible degree of 3, knowing that it could be higher, which again is why that word least is there, okay? So again, how do I know the number of, or the least possible degree? It's the number of turning points plus 1, okay? But I also explained obviously far more about that. Let's look at our next one. We've got first our x-intercepts. So let's look at this one. That one, that one, that one. This is going to be our x. This will be our y. So our first one there would be 1, 0. Our next one is 3, 0. And the last one is 6, 0. Okay, let's identify our turning points. So our turning points here, again, we're going to start on the left side of the graph, wherever that is. So this is going to be going down, down, down. Okay, here's a turning point. Back up. Oh, turning point. And that's right on top of a x-axis or x-intercept there. And keep going, turning point. And then we keep going. Okay, so how many turning points do we have? We have 3 in this case. And then our least possible degree will be +1 to have 4, which makes sense. This is a pass-through, this is a pass-through, this is a bounce. So this would be at least a multiplicity of 1, at least a multiplicity of 1, at least a multiplicity of 2, and 1 plus 2 plus 1 gives you 4. Okay? All right, so hope that helps give a little context to how turning points and degrees and multiplicities kind of all connect together. Let me do the reverse of this, though. I'm giving you the graph right now and asking what the least possible degree is. Let's look at what would happen if I gave you the function and ask the reverse questions, okay? So if I'm given the function, let's look at this first one, f of x equals 4x squared minus 6x to the 5th minus 10, then it's asking there are at most blank x-intercepts and at most blank turning points. So the key here is that the degree of the graph, the degree n of the graph, that's going to be the x-intercept. So n is the x-intercepts. Okay, so our x-intercepts would be degree. What is our degree of this function? The degree of the function, I should say. What's the degree of this function? So our highest, am I adding? Am I adding here? What am I doing, y'all? What form is this function in? Is it in factored or standard? This is in standard form, right? So because it's in standard form, we're not adding. I know we've just done that a whole bunch, but we're not adding here. We're looking at just the highest degree, okay? So if you need to make a note on that, make a note, okay? So this would be 7, degree 7. Now, there are at most n minus 1 turning points. So it's just the reverse of what we just did with the graph. So going from here to here would be subtracting 1. So 7 minus 1 gives me 6 turning points. And you can see the relation. If I start off with the degree, then I'm subtracting 1 to get the turning points when I have the graph. Okay, so really you're just, the x-intercepts is the degree, turning points is 1 less. Let's look at the same thing for this next one. Careful here though. Number 1, it's in standard form, so don't add. But also, it's not in descending order. So we're looking for just the highest degree, or you can rewrite this if you want. But our highest degree here is 9, and then our turning points is 1 less. So this would be 8. Be so careful though. I'm going to tell you right now, that's going to be tricky, and the computer will trick you. So make sure you're looking for the highest number when you're doing the degree there.